Okay, so today we are doing rate of change. And the rate of change is just how much the numbers change for each step. So if we've got this pattern here, it changes 3. Well, we know that. We already done that before. We call that the common difference. But the difference is 3. Each step, it changes 3. Well, if each step changes 3, well, then that means the rate of change equals 3. So you can kind of think of the common difference as the rate of change, because that's what it is. It's how the numbers change each time. Okay, but now when we're looking at patterns, we don't always know all the numbers. Sometimes there's a missing step. What if we don't know that step? Well, we can still see how far it changed past that step, and from the 3 to the 7, I know it added 4. But that's not just one step. That's 2 steps. Okay, so it changed 4, but that was in 2 steps. I don't want to know how far it changed in 2 steps. I want to know how far it changes every step. So if you know the change and how many steps it took to get there, you could just divide how much did it change by how many steps did it take, and that will give you the change for each step. So in other words, all I have to do is 4 divided by 2, and I get 2. So the rate of change is 2, because if it moved 4 in 2 steps, then that means it's moving 2 each step. Okay, now, most of the time you won't see them as sequences, but you might see them as tables. So here's an XY table. Now, this means the same thing as a sequence. The only thing you have to know is that the X tells you which step you're on, and the Y tells you what the number is. Okay, so if I'm looking at, let's say, this 4 over here, okay, that means at step 4 the number is 16. At step 3 the number is 12. At step 2 the number is 8. At step 1 the number is 4. So I can use any of these steps and any numbers that I want. So if I look from 4 to 8, that's plus 4. And if I look at the steps from those two, it's from 1 to 2, so that's 1 step. So that means my rate of change is going to be 4, the change, over the number of steps, which is 1. So I get 4. The rate of change is 4. But also, I don't have to use the first 2. I can use any 2 I want. I can look from the 8 to the 16. That's going to be plus 8. And if I look at the steps for those 2, it's from the 2 to the 4. Well, that's 2 steps. So that gives me 8 over 2, which is also 4. So that tells me the rate of change is 4. So as you can see, it doesn't matter which 2 points you use, which 2 numbers you use, you get the same rate of change either way. Okay, so now that we have a little bit of understanding of rate of change, let's really talk about what it is. Okay, rate of change is really just the vertical position, how it changes, over the horizontal position and how it changes. Okay? Now, if you think about a graph, the vertical change, vertical is your y coordinates. So this is going to be your change in y. And moving side to side is your x. Horizontally is x, so that will be your change in x. These are the same thing. So you can think of rate of change as either the change in y over the change in x, or the vertical change over the horizontal change. Now, if you're looking at points, it's easier to use this one because you see x, you see y. Okay? But if you're looking at a graph, it may be easier to think about this one because you can see how the graph moves up or how the graph moves over. Okay, so now let's take a look at a graph. Okay, I'm going to put 3 points on this graph, connect them with a line, and now let's look at it. Okay, I've got 3 points. I've got this point here, and this point here. Now, I could write these points down. The first one is 0, 0. The second one is over 1 up 2, so that's 1, 2. And the third one is over 2 up 4, so that's 2, 4. Now, whether I use the points from the line or the coordinates over here is fine. If I want to use the coordinates, I can use change in y over change in x. And I can see how the y values change and put that over the x value change. Okay? Which, if I'm looking at these y values, if I go from 0 to 2, that means the y changes by 2. If I look at the x, it goes from 0 to 1. That means the change in x is 1. Well, 2 over 1 is 2, so my rate of change is 2. Now, I could also look at the graph. If I'm looking from, let's say, this point to this point, then I can just count how far up does this go. Well, it goes up 2. And then how far over does it go? Well, it goes over 1. So that means my vertical change was 2. My horizontal change was 1. So my rate of change is 2. Either way, my rate of change is the same. Okay, whether you want to use the coordinates and use change in y over change in x, or use the graph and do the vertical change over the horizontal change, it's the same thing. Okay, now I do want to go ahead and give you the formal formula. Okay, rate of change equals y2 minus y1 over x2 minus x1. Well, doesn't that just mean the change in y's over the change in x? So if I have 2 points, let's say 6, 2 and 3, 4. Okay, then I can call this one x1 and y1, and I can call this one x2 and y2. So if I do y2 minus y1, I have 4 minus 2, and I do x2 minus x1, I have 3 minus 6. So now I do my subtraction. 4 minus 2 is 2. 3 minus 6 is negative 3. So my rate of change would be negative 2 over 3. And that would be my answer. Okay, now you need to find the rate of change of each of these three lines. Okay, so looking at the blue line, I look at how far it goes up and over. It goes up 2 and over 2. So the rate of change is 2 over 2. So the rate of change is 1. Then for the pink line, it goes down 3 and right 2. So that's negative 3 over 2. The yellow line goes up 1 and right 3. So that's 1 over 3. There's my 3 rate of changes.